All right, guys, welcome back to SGLang Office Hour. I think like this week we want to do something different before we go straight into the topic. So probably we can like chat with Khoa first. Like Khoa is one of our SGLang community member. Can you like quickly introduce you to people on the live stream right now?
Hello everyone. Thanks for joining. I'm Khoa. I just made my first contribution to SGLang. I want to say a month and a half ago. So yeah, very excited to be here. And I'm also worked on this Gemma 4 Day Zero support for SGLang. So happy to give this talk and answer any questions you guys have.
That's pretty cool. So I was wondering, what's your journey of like discovering SGLang? So how do you know this project?
I think I've been working on ML system for almost a year now, and as you know, SGLang is the state-of-the-art inference engine, open source. So I think everyone in the industry knows about SGLang. I think, and then the last, I want to say 6 to 7 months, I've been trending towards more inference work. So that's how I got introduced to SGLang.
That's amazing. So if there's one thing that like I know you have been working with for SGLang for a while, and if there's one thing that would like to improve SGLang, what would that be? You could be the documentation. You could be like something you would like to you wish that could be better. And
I think very on theme for this talk would be NVFP4 support across all Gemma 4 variants. We would love to see that going. And a couple more surprise coming up as well.
Oh, perfect. Yeah, one final question. So can you tell us the fun facts about you?
Fun fact about me. I think fun fact about me is I use Asian coding very heavily even before the November of 2025 where Opus dropped Opus 4.5. I was working at a coding agentic company before, so I was heavy user even back then.
I see. Are you using like something like Cursor or just like the click-based agent like the Cloud Code?
Something like Cursor.
Oh, perfect. Yeah. Okay. Let's go back to the topic. So Google last week they launched Gemma 4. So it's an open model family with 4 model size and also with the permissive license. So we got help from Google and also the community member at SGLang. We're able to support the model on day 0. And like Khoa say, he is the guy that work on the Gemma 4 support for SGLang. I'll give the stage to you.
Cool. Let me switch to my presentation. Can everyone see the screen? Everyone good?
Yeah, I can see it.
Cool. So today we'll talk about Gemma 4. There's a couple of agenda here. So some Gemma 4 architecture highlights. I know Gemma 4 architecture is very, very different from what's out there. But I think these are some of my personal highlights that I run into when I develop this model for SGLang. And then with those very novel architecture, we have some challenges, of course. And I will present those challenges and solution of how we deal with it or work around it. And then finally, I want to give it instructions to run Gemma 4 across multiple hardwares and spend some time at the end for Q&A. Cool. So let's jump right ahead into Gemma 4 architecture highlights. So we will start with the very small models, effective 2B and effective 4B. These models are honestly very different from what I've seen before. We have per layer embeddings. So as you can see here, after FN, there's a per layer embeddings. And then this model actually reuse KV cache of previous layers. What does that mean specifically? So the first 20 layers out of 35 in E2B will write K and V activation to the KV cache, but then the last 15 of layers will read those KV cache from the previous 20. Specifically, if the layer, let's say, if the last local attention layer is I, then and the next local attention layer is, I don't know, J, then layer J would reuse KB cache of layer I. Same relationship for global attention layers. It will try to reuse the KB cache of the last shared global attention layers. Actual config there is the first 20 layer will write to a KB cache. The last 15 will read from it. For E2B, for E4B, that is 18, and this is, I believe, 23. Yeah. Cool. And then next one is for E2, or for many model in the Gemma 4 family, they have alternating local and global attention. Local here is sliding window attention, global is UQA. And these attention layers have different head dims. The specific ratio is for E2B, there are 4 local attention layers followed by 1 global attention layer. And for E4B, there are 5 local attention layer followed by 1 global attention layer. And the head dim for the local attention layer is 256, and the global attention head dim is 512. This is very interesting, and we will go into it shortly. And lastly, these models support all 3 of image, video, and audio input modality. I think there are many points to talk about how Gemma 4 does its patching and resizing for image. I think there's like a very long blog post on Twitter about it. I think the technique is very novel, but for the sake of this talk, we will not focus on that part. And I just want to highlight here is that for the image and video, for the vision attention part in the image tower, there's a QK norm and there are no attention scales. This is actually the first time we've seen this in SGLang. And so if you look at the code base right now, there'll be a plumping change to support it. Cool. I'll quickly pause here for any questions if people have. I know that was a lot to cover for E4B and E2B. Any questions? Okay, I don't think there's any questions, so I'm just gonna move forward. Next two are the 31B variants and the MOE 36B 4B activated. For these model, again, it's the same alternating local and global attention pattern with ratio 5:1. Same dual head dim 256 512. One very interesting config here is attention K equals V. So all the K and V produced by the QK view projection has to be the same, so it's true. And 31B and 26B model support image and video input modality. It doesn't support audio. And same with the previous one, it needs QK norm and no attention scales. One difference here is it actually does bidirectional attention for the visual tokens. We'll go into that in a little bit. Cool. Yeah, let's just go ahead into the challenge and solution section. So as I mentioned previously, the global attention head dim of 512 caused some amount of pain point here. First headline is global attention head dim 512 break pretty much every attention backends. This include FA4, FA3, FA4, /infer, CRT, MHA. So for day0 support, we have to make Trident the default attention backend. I linked a PR here from the /infer side for head dim 512 support. Once that's went in and we updated /infer version, we can enable TRTL MHA as the attention backend. Secondly, so making trident the default attention doesn't actually fix the whole problem. One interesting detail here is we also need to maintain a separate sliding window attention lockets in the try and decode kernel. Let me just pull the code base. Yeah, so okay, here it is. Cool. So in order to make this work correctly for our try and backend, we have to add a separate attention lockets. This is specifically relevant when the VHAT dim is different. I'm not gonna walk you guys, all over this code, but the key takeaway here is our some of our striding logic depends implicitly on the division of VHAT dim, and not every model has not every model has the same VHAT dim across every layers. Specifically for Gemma, this is the case where full attention layers and global attention layer and local attention layer have different VHAT dim. And so this actually breaks during our early testing. In a very funny story, it breaks for the audio benchmark. Some of our audio benchmark were very decode heavy, and we only caught it during audio benchmarking. So I spent like 2 days looking at the audio tower implementation and see nothing wrong with it. And turns out the reason why it's wrong is at the text decode layers. Very, very funny experience. Yeah, so coming back to the slides here. And another, oops, sorry, let me present it. To head him. Yeah, and another problem with the dual head dim approach is the sliding window attention KV cache pool has to maintain a pool for global attention and a pool for sliding window. Each have different head dim size. Fortunately for me, this is already implemented in SGLang before I start my Gemma 4 work. I think very shortly before I start my Gemma 4 work, actually. And as far as I can remember, I think the MIMO V2 flash model also have the same characteristic. So I didn't have to implement this. I just need to know that it exists and use it. And okay, maybe I'll stop here for any questions or comments. What is this nomenclature? It's for the parameter count. So effective 2B means effective 2 billion parameter. Effective 4B means effective 4 billion parameter. 26BA4B is 26 billion, 4 billion active per token, and 31B is just dense. We saw BRI goals per layer head dim dispatch for Gemma 4. This next step, getting Gemma. Yeah, great question. So not sure about FA3 specifically, but we will. So the plan as of today is to enable TRT LLM MHA across all layers. And in order to do that, TRT LLM MHA has to support head dim of 512. And I think FlashInfer has planned to support that in the next, I don't know, couple of weeks. Cool. I'll just move forward. Yeah, again, one more problem that I highlighted in the beginning is KV cache sharing for E2B and E4B. I think this might deserve some drawing here. So let's see. Let me know if you can see my drawing. So let's say that is global. Okay, this is like a fake drawing, but let's say these and then these layers are KV cache reuse. Oh, sorry, shared, and then the rest are reuse layers. So the pattern for E2B and E4B is that this layer would take the KV cache of this layer, and this layer would take the KV cache of this layer. Now, one interesting thing that happened there is for most architecture, we would allocate the KV. Let me go back to my slide. For most architecture, we would allocate the swell KV pool for all layers, and then at each layer we will set, say if KV cache equals to true, and then each layer will write the KV into its KV cache, so on and so forth. But for E2B and E4B is very interesting because the last 15 or 23 layers doesn't have to have a separate swell KV cache pool. It just needs to retrieve from the previous layer. However, we still allocate the full swell KV pool for all layers, but we just set for the ease of implementation, we just set the save KV cache to false for the later reuse layers. And if the reuse layer, if the layer is reused, then we force the attention backend behind that layer to retrieve the KV cache of the previous layers, of the shared layers. Quick stop here for a question. I think I saw something. Okay, I will respond to that in the end. Requires user warning or repeated understanding. Gemma 4 requires frame timestamp to construct prompts, but the FPS of the input video could not be inferred. Interesting. Kind of hard to answer that off the top of my head, but I think it could be a transformer version issue. Most likely, make sure you're using the right target image, or if you're building from off the latest main, then you would need to have the correct transformer version to support Gemma 4. Looks like it may need Quen 3 VL style reprocessing. Not that I'm aware of, no. I think the best is to find an issue, and then we'll take a look after this office hour. Yeah. But I didn't run into data understanding problems for Gemma 4. Okay. Yeah, thank you. Back to the presentation. Yeah, one more highlight here is the 31B and 26B A4B visual attention has to be bidirectional. If any of you in the audience are familiar with how we implemented Gemma 3, we also have to specify the multimodal attention backend to be trident because of this bidirectional support. And also, I think fundamentally, because of this bidirectional mask, the visual tokens are very, very sensitive to any sequence sharded solutions. like chunked pipeline prefill, chunk prefill, or sequence parallelism. Make sure the image, we put that as a warning as well for Gemma 3 and Gemma 4, but make sure during setting up your server, you don't set chunk prefill to be something that slide through a range of visual tokens, because that will break bidirectional attention. I am referring to, more specifically, I'm referring to this. Where's my vision attention? Where is this? No. This is awkward. What's the function called again? Mass by. Okay. Somewhere in the Gemma 4 vision file. I'll take a look later. Okay. Yeah, I guess pause here. Questions? FPS may not be set properly in the metadata, or its variable frame rate. Right. Yeah, that's definitely one possible reason. Okay. Anything else? Okay, let's go back here. Yeah, I think this is the section that most people here are waiting for. It's just instructions to run Gemma 4. So we have support across multiple hardwares, popular one like H100, H200, B200, GB200, and GB300. We have Docker image for H100, H200, B200, and for the Grace Blackwell separately. As mentioned before, the TLT, LLM, MHA attention backend is coming soon, and the NVFP4 31B is also ready soon. All of this hopefully should go in the next release of SGLang, which is 0.5.11. Stay tuned on that. And we have support across the AMD GPU as well. So MI300X, MI325, and MI355. And thanks to AMD, we have either backend available on day 0 for the 31B and 26B version. Yes, thanks again for AMD for that. And you're always very welcome to check the SGLang Gemma 4 cookbook for more details. I put the link here. Let us know if you run any questions, if you have run into any issues running this model with our Docker image or our PyPy nightly, and we'll try to answer them. With that, I think that's it for this presentation. So once again, thanks so much to our collaborators, Google, AMD, NVIDIA. Couldn't have this day zero support on time without your help. Thank you so much.
Great. I think we can go to the Q&A section, but since we already answered so many questions along the way, yeah, I think we have the question in now.
Which Docker specific task? So if you go into the code, yeah, let me just help you out here. So these two, if you can see my screen, let me know if you can see my screen. So these two are for the non-Grace machine. So any AMD 64 will work here. The first tag is for a machine with CUDA less than 13, and then the second one is for CUDA greater than or equal to 13. And then for the Grace machine, we also have two specific Docker image for them as well. I think most Grace machine is CUDA 13, not 100% there, but yeah, if your machine is CUDA 13, just use this tag and it should be good. Does ITER replace RockCam? My understanding is no. They are two different backends. They probably have their own trade-offs. Yeah.
It might be some delay for the comment from the stream, so we can wait for 1 or 2 minutes to see more question coming. Are
CUDA and Triton used at the same time? Not sure what you mean here, but I guess I can be specific here. So by attention backend, that means for just the attention kernel that we're using Triton. Across the board, CUDA is still being used just fine. And also Triton does compile to some PTX extension. Will Gemma 4 have support in Ohm? In Ohm. Did you run into any issue when trying Gemma 4 on Ohm? As far as I understand, if as long as SGLang support it, it should be supported in Ohm. Yeah, sorry, just say that one more time. As far as I understand, as long as SGLang supported, it should be supported on OME. Any best practice for configuration? Yeah. So we can release something deeper for configuration tuning, but these models are pretty small. So the rule of thumb is if you are running with low concurrency or small batch size, just run the model on single GPU. If you're running on high concurrency, especially for the dense model, 31B dense model, you can run it with TP equals 2 or TP equals 4. I see. Yeah, we probably have to update something on the Ohm side. since Gemma 4 alternate layers, would SGLang know which needs more or less for KV caching? Great question. So let me go back to my slide. Yeah, I could have delivered this point better, but our Squad KV pool maintains two separate memory pool. One is full KV pool for global attention layers, and the other is SWA KV pool. So to your question, yes, we are aware of how to make. Sorry, what's the correct wording? Yeah, SGLang knows which needs more or less for KV caching. What is the expected token per second for P200? History. This is a little hard to answer without knowing your workload. It's 300. I would say that's without knowing more information, I would say that's pretty reasonable. Yeah, I'll leave that for now. Again, if you are running any problems about performance, you can create an issue and we'll take a look at it. But I think I saw some people also talking about this, but a lot of the bottleneck is on the trident attention itself, which is very unfortunate. So hopefully when TRTL and MHA coming out, we'll have seen less of these performance issues. I'm also interested in stats. We don't. I think GitHub Action is not that good reference. Yeah, that means the tests are often skipped. It's hard to give a expected number for throughput without knowing more about the concurrency level and the generally how long your what is your context length, what's your batch size, and any server config that you run. So yeah, it's a bit hard to give an estimate for throughput.
Besides all those technical questions, I also love to know from the comment section what exactly you use Gemma 4 for. What do you deploy Gemma 4 in your actual use case? We would love to know as well. But for Khoa, did you see someone from the community actually using Gemma 4, for something?
Yeah, I think I saw a couple of posts on Twitter about using. I think there's two group of people. One is using the E2B and E4B as as a local or edge inference device. Edge model assistant, because the E4B and E2B are very small models and they have actually very great understanding of image, video, and audio for their size. So I could definitely see them being used as edge inference model on the device, stuff like that. And then another group of people use the third one B as a bigger inference, slightly bigger inference workload for, say, having an H100 GPU and run 31B as a personal assistant, or general daily use chatbot, stuff like that. I've also seen some report on the community, but this is still very new, is that the 31B model, despite not winning on every benchmark, is pretty generalizable and fine-tunable.
Yeah, I saw a lot of people they're using the Edge version of the Gemma 4 like for doing OCR stuff and also labeling things.
Hmm?
Oh yeah, we have a comment.
Yes. The Gemma 4 integrated games. The Gemma 4 E2B and E4B is definitely very interesting.
Yeah, and I also like see people like running the 31B version with the Mac Studio for OpenCloud, and they say it could actually replace a lot of like workflow in the with OpenCloud like to replace some like much bigger model like Q and Minimax. Yeah, it's incredible. Kawhi, can you again like talk about what's our future plan to bring more support to the Gemma 4 model and
Yep.
what could be the timeline and why are we doing that?
Yes. So one more time, we will support TRT, LLM, MHA backend soon. We will support the NVFP4 of the lens model soon. And yeah, I think that's mostly it. And perhaps the MOE NVFP4 checkpoint as well. Yeah, those three things. So you should expect to see great improvements on performance for those because of those three additions.
Amazing. Yeah, we have a new comment.
Can S3 run on macOS? I'm actually not super familiar with the MLX backend. So hopefully someone else in the community could share some lights there.
Yeah, feel free to join our Slack channel. I think we have someone in SGLang Slack channel talk about how to run SGLang with MLX backend. Yeah, there's definitely some people trying to do that.
Yeah. Yeah, I definitely saw some diffusion support on macOS.
I think we'll take either one or two more questions. And we can move forward. And we have some good news to share today as well. Oh, and by the way, I think Google has the iOS app called I think it's called Edge AI Library. It natively support Gemma 4. I think the inference that they did on the edge on device is pretty good. It's very fast and also reliable. Yeah, I think that's all the question we have today. Okay, so let's move on. So if you haven't do that, go check out GitHub repo and start us if you haven't. And please follow our X account. And you're going to see like the latest thing about SGLang, like the Daisy support for Gemma 4 last week. And the good news to share today is so today we launched a new course to talk about efficient inference with SGLang with deep learning the AI right now. It's open and free to everyone, and it will just take you around a little bit over 1 hour. So basically the course like cover how inference works with SGLang with the Redis attention. We also talk about diffusion model, like how caching works with diffusion model. And of course, we talk about like how AI inference is headed and what comes next. Like Jack supports like one engine for all the modalities, stuff like that. So go check the course. I think this is a wonderful guide if you like to learn or get your hands on SGLang. And we thank Deep Learning.ai for this opportunity. One final thing is like, again, we have a Luma calendar. We are going to have upcoming events. We're going to put that on that, and also for the biweekly office hour, we're going to put that as well. And please subscribe, and follow the Luma calendar that we have. All right. Thank you so much for today, and of course, thank you, Khoa, for being here and talk about Gemma 4. Thank you so much, and see you at the next office hour. Thank you.
Thanks everyone for joining. Bye bye.